All right, back for day 2 of the last week of school. So yesterday we did square root functions, and today we are looking at simplifying radicals. So remember yesterday we talked about what a radical is, right? It's anything that has that radical sign, it's a circular definition, but like what you would think of as a square root sign. So when you simplify radicals, what it means to be simplified, so it's kind of like, you know how like if you have like 2/4, right? That's not in lowest terms, it's not a simplified fraction because there's a factor of 2 that goes into both of those. So really your simplified version of that is 1/2. So simplified radicals are kind of the same thing. I mean, they don't always necessarily have to do with fractions, but a simplified radical is a radical in which there are no perfect square factors. Remember that factors means like numbers that you can multiply together, right? So to have perfect square factors would mean that there is a perfect square that you can divide out of a radical. So no perfect square radicals other than 1. Okay, so you almost like, no, never mind. I was gonna say it's like prime numbers, but it's not. So what you want to really have at the top of your head here are these first 20 perfect squares, because you're going to want to recognize those as factors of other numbers. So we're just quick going to do this. So square root of 1, of course, is 1. Square root of 4 is 2, 3, 4, 5, 6. This goes all the way down. I almost skipped 8 by accident to 20. So when you do this, like you're going to want to take a look at a radical. So let's take like the square root of 12. All right. So if you look at 12, there's a whole bunch of different factors of 12, right? We can remember chapter 8 when we looked at like factor pairs for Gray's common factors. So you could have, 1 and 12. You could have 2 and 6. You could have 3 and 4. So now instead of just like trying to factor it or trying to rewrite it in a different way, you want to rewrite it as a product of 2 things, but in a very specific way. You want to write it as a product, if you can, of the radical of a perfect square times whatever your other factor is. So if you take a look at, these 3 pairs of factors for 12, you have 1 and 12. Neither of those are perfect squares, right? So this is our list of perfect squares on the left. None of those are perfect squares. 2 and 6, also not perfect squares. 3 and 4, well, 3 isn't, but 4 certainly is. So you would write the square root of 12, you would rewrite that. So write 2 different radicals, and you write it as the perfect square, which is 4, times the square root of its other factor, which is 3. So if you have the square root of 12, I can write that as the square root of 4 times the square root of 3. And the reason why you want to do that is because I can take the square root of 4, that's 2. The square root of 3 is as simplified as it can be, because, like I just said, simplified radicals are radicals in which there are no perfect square factors other than 1. I can't break 3 into any multiplication of perfect squares. So I actually just keep it the way it is. So really, like the square root of 12 and 2 times the square root of 3, those are equivalent, right? Just like if you had x squared plus 7x plus 12 and you had x plus 4 times x plus 3, those are equivalent expressions. It's just another way of writing the same thing. So this 2 times square root of 3, that's a simplified form. So this is our goal today, is to get all of our numbers, when we can, down to a simplified form. All right? Okay. So the big thing on this is that you do not use your calculator for this, because like what I just did, right? So if I put the square root of 12 in my calculator, I get 3.464101615 and so on and so on and so on. That's not simplified. That tells me the decimal form of this, but I don't actually care what the decimal form is. I want a simplified radical. There is no way to do simplified radicals on this particular calculator. All right, so you kind of want to shelve your calculator unless you're trying to find factors. So we have our steps here, and I kind of just did this on the other page, but to simplify a radical, first you divide out the largest perfect square that goes into it evenly. You can divide out any perfect square that goes into it, but if you find the largest, there's a benefit to that. It means you only have to do it once. If you don't find the largest perfect square right away, then you'll have to continue to simplify. And I know that you guys like to do things quickly. So finding the largest perfect square is the best idea. And that's why you should keep this sheet that we just looked at with you, because this will help you quite a bit. Okay. And then you take the square root of that number, and then you leave the rest under the radical. So if you want to kind of see what that means in this, so this was step 1, right? We divided the largest perfect square out of it. So we divided out 4, and we rewrote it as square root of 4 times square root of 3. And then we took the square root of the perfect square, which was 2, and we left the rest under the radical. All right, so square root of 8, again, like most of the ones I give to you will not be simplified, so you will have to simplify them. So you can go about this a couple of different ways. Okay, you can think about just factors of the number, right? So, okay, well, I have 1 times 8, and I have 2 times 4. And I look and see if any of those are perfect squares. And again, 4 is. So I'm going to use 2 and 4. So 4 is my largest perfect square, because it's my only perfect square. And I write underneath the radical, underneath the first radical, I write the perfect square. Underneath the other one, I write the other factor that goes into it. So this would be 4 times 2. And then I take the square root of 4, which is 2, and then I leave the square root of 2 as it is. So my answer to this is 2 rad 2, or 2 times the square root of 2. The reason why you write the perfect square first, by the way, you're like, does that matter? It does. Because if I write this as the square root of 2 times the square root of 4, and then I have a square root of 2 times 2, like it's the same thing because multiplication is commutative, so I can multiply it in that order. The problem is that sometimes people get a little crazy with the square root symbol, and so it's hard to see in every instance whether this 2 on the right side belongs under that or not. So if you put it on the left side, it just takes away that wonder. Okay, so I'm going to show you the other way that you can do this. So I have the square root of 50. Okay, so I'm going to take out my handy dandy chart. And nothing can go into 50 evenly if it's over 50, right? So I'm going to go down this chart, and I'm going to stop when I get to a number that's over 50. So 64 is my first number over 50. So that's not going to work. So I'm going to take every one up here, and I'm going to start here. And I say, okay, if I do, and you can use a calculator for this. I mean, obviously, a lot of them you won't need to. You'll just know. But for funsies, we'll take a look. So I divide whatever my radical is I'm trying to simplify, so in this case 50, divided by 49. And that clearly does not go in evenly. So what you're looking for when you divide is a number that would go in as, that would be another whole number. Okay, so 49 is not going to work. So now 36. And of course, obviously, it's not going to work either. So now I move up my ranks to 25. Boom. So I got 25 and I get a whole number of 2. So that is how I'm going to split this up. And the reason why I started down here is because if you start with the highest possible number that could be divided out of it, and you move up your ranks of perfect squares, then you know that you have the largest one. That'll really come in handy in the next problem we do. Okay, so the square root of 50, the largest perfect square was 25. So I'm going to write my perfect square of 25. My other factor was 2. Take the square root of 25, and that's 5. And then square root of 2 stays the square root of 2. So 5 rad 2. All right, now let's take a look at 72. So I go back to my handy dandy chart, And I said, okay, if I go down this list, what's the largest number that could possibly be divided out of 72? So the largest number under 72, that would be 64. So you would divide 72 by 64. And that, of course, does not work out evenly, so you go up to 49. 72 divided by 49. That does not go in evenly, so you go up to 36. And it's 2. And again, like not all of these are 2. It just so happened that that's the way I wrote this, so I apologize. Don't think that that's always the case. So 72 is 36 times 2. So I put 36 in the perfect square, 2 in the other one. Take the square root of 36, which is 6, and then square root of 2 stays the square root of 2, so it's 6 root of 2. All right, but like I said, on this one, you can really see the reason for trying to find the largest perfect square. So if I look at, again, if I look at 72. So let's say I looked at this sheet here, and I started at the top. And I said, well, 1 obviously goes into it, but 72 times 1 doesn't do me any good. And so I try 4, and I get 18. And I'm like, oh, cool, I have a perfect square. So I'm going to say, well, 72 is the square root of 4 times the square root of 18. So I'm like, 2 rad 18, I'm done. No, you're not. Because guess what? 18 is not simplified. So you're like, well, shoot, I have to do this again. So you have to take this one down because that's already there. And then I have to split rad 18. And I'm like, okay, what goes into 18 that's a perfect square? Well, 1, obviously that doesn't matter. 4 does not. 9 does. All right, so there's the square root of 9 times the square root of 2. And so I still have that 2 hanging out. And then I have the square root of 9, which is 3. And then I have the square root of 2, which I keep as the square root of 2. And now I can multiply these together. So 2 times 3 is 6, and then the square root of 2. So look at that. I got the same answer, but I had to do 1, 2, 3 times instead of just 1. So that's why it's always beneficial to start at the higher perfect squares and work your way up rather than the lower ones. Now, there are exceptions to that rule. One of them being if you have like a really large number that you're trying to simplify, like say, the square root of 500 or something, then you're going to want to maybe start at the top, because starting and going everything from 484 up is going to take a long time. Oh, speaking of, there we go. There's a 300. So I have 2 things I could do. Well, actually, this is the only thing that's going to work. So I kind of don't want to start at 289 and go all the way up, right? 300 divided by 289, 300 divided by 256, 300 divided by 225, and so on and so on and so on. So this is one of the ones where it's such a big number that I'm just going to think of things that might go into it. So obviously don't do 1. Let's go 300 divided by 2. That's 150. Well, 2 is not a perfect square, neither is 150. So 300 divided by 3. 3 is not a perfect square, but guess what? 100 is. So that's 100 in the perfect square column, and then 3. The square root of 100 is 10. Square root of 3 stays the square root of 3 because there's not a perfect square factor. And if you wanted to use this little box on the right, this is factor. So I have 1 times 300, 2 times 150, 3 times 100. And then I could just keep going like that until I found a perfect square. And then, talk about the largest perfect square here being 100. So that's what this factor column is for. All right. We're just going to do a few of these because I feel like once we get the hang of it, it's pretty good. So 48. Again, I could list all the factors of 48 over here, or I could go to my handy dandy perfect square chart. I could say, okay, what's the largest possible number that could go into 48 here? Because it's a low enough number, I can do that. That's 36. So 48 divided by 36 is not going to give you a whole number. 48 divided by 25, also not going to give you a whole number. 48 divided by 16 will give you 3. So my largest perfect square factor is 16. My other factor is 3. So this goes square root of 16 times the square root of 3. Square root of 16 is 4. And the square root of 3 stays the square root of 3. So there you go. So now might be like a decent time to kind of tell you like some pretty common simplified radicals. That way you know if like you really need to go on anymore. Okay, so all prime numbers are simplified radicals. Because if you remember what a prime number is, a prime number, its only two factors are 1 in itself. So if it's a prime number, like there's nothing that you could multiply together to get that number if the only factors are 1 in itself. Okay, so all prime numbers are simplified radicals. So that your prime numbers, remember, like 2, 3, 5, 7, 11, and so on and so on, right? But some of your other simplified radicals that are not prime numbers that they look kind of tricky. So like 6, rad 6 is a simplified radical. Rad 10 is a simplified radical. It doesn't look like it should be because you're like, stuff has to go into 10. Well, sure, 2 and 5 do, but again, none of those are perfect squares. 14 is also a simplified radical because its only other factors are 7 and 2. So there's a whole bunch that are like even numbers that are big that look like maybe they should have perfect square factors, but they don't. And if you're like, I just have no idea whether they do, that's why you have this chart. So if you're ever not sure, just take that strategy that we did already and divide by first the largest one that can come out of it and then go up the sheet from there. All right, so 75, square root of 75. Now again, like I know that there are some of you watching this going, oh my gosh, Mr. Shigley, it's so obvious it's 25. Well, yeah, no kidding, right? If you already know that, do it. Like you don't have to go through this process of start at 64 and then 49 and then 36 and then 25 to see that 75 is 25 times 3, right? So again, if you already know that, just write it down. If you don't know that, then for sure, go through that process. So square root of 75 is the square root of 25 times the square root of 3, which is 5 times the square root of 3. All right, let's take a look at 98. So square root of 98, again, if you go on this chart here, the largest possible number you could use is 81 because 100 is over 98, so that would not be able to work. So you can just start 98 divided by 81, and you get a decimal. 98 divided by 64, and you get a decimal. 98 divided by 49, boom, there it is, it's 2, right? So your square or your perfect square here is 49, and your other factor is 2. And remember, like the most important thing, well, there's two most important things. That first of all, this one's a perfect square. Second of all, that these two multiply together to get what was under your first radical. So that's really, those are the two things that need to happen here. So the square root of 49 is 7. Square root of 2 stays the square root of 2. All right, 24. Well, let's think. What are the this one's a small number. It might just be easier to think of what are the factors of 24. So 1 and 24, 2 and 12, 3 and 8, 4 and 6. Not one of these, except for this one right here, is a perfect square. So it's 4 and 6. That's the factor pair I'm going to use. So square root of 4 times square root of 6. Square root of 4 is 2. Square root of 6 is simplified. Remember, that's why I said before, rad 6 doesn't look like it's simplified. It looks like you should be able to take something out of it, but you can't. All right, 63. Go back here. The highest one I could possibly use is 49 because 64 is over 63. So 63 divided by 49 does not work. 63 divided by 36 does not work. 63 divided by 25 does not work. And again, most of these you can do in your head, so please do. I'm just showing it to you. 63 divided by 16 does not work. 63 divided by 9 is 7. All right, so square root of 9 times the square root of 7, and the square root of 9 is 3. Square root of 7 stays the square root of 7. I'm going to jump down to this one right here, this square root of 243. So 243, again, is one that you could kind of do two different ways. You could go to your sheet here, and you could start at 196 and go up, and it wouldn't be too long until you found it. Or you could just start dividing out like small numbers to see which whole number goes into it first. So let's try that one just to practice that way too. So 243, obviously don't worry about 1. And then if you divide by 2, like you should already know that's not going to work because 243 is not an even number. 243 divided by 3. Ooh, that's 81. All right. So 81 times 3 is 243. So square root of 81 is 9. And then square root of 3 is the square root of 3. And I picked this one to do because so many people like want to do the square root of 9 again here because they're like, oh, 9's a perfect square. I have to do it again. So it's 3 root of 3. No, you don't. There is no square root sign around 9. You already took the square root of 81 and you got 9. So that's where you stop that. So even if like you take the square root here and that's still a perfect square, it's supposed, like, that's fine. Don't worry about that. Okay, so your answer here is 9 times the square root of 3. All right. There's one other thing I have to show you, and it's actually from this like simplifying radical expressions kind of homework thing. So what you should notice on here is that you have letters. So we're moving some variables in here. So some of these are already perfect squares, by the way. Some of them you need to simplify. And then we also have to figure out what to do with these variables. So what I want you to do is follow a couple steps. First of all, split the radicals into numbers and variables. All right, and then I would have a different radical for each variable you have. So like if you take a look at this first one on number 3, you have C and S, and so I would have 2 separate radicals for that. All right, so let's take a look at number 1. So the first thing I'm going to do is I'm going to rewrite this as the square root of numbers and the square root of letters. So the square root of 64 times the square root of y squared. Okay. Well, the square root of 64, I don't have to simplify that like into 2 different radicals because that is a perfect square already. So if it's a perfect square you're dealing with, all right, just take the square root. So square root of 64 is 8. Now, the square root of y squared. Well, y squared, remember, is y times y. And whenever you are taking the square root of something, you're trying to find what you multiply by itself to get that. So anytime you have an even radical here, or an even exponent in a radical, the square root of it is just the exponent divided by 2, right? Because this is y to the first times y to the first. Let's say you have like y to the 4th. Well, that would be y squared times y squared. Because remember, with the rules of exponents, when you multiply things with the same base, you add their exponents. So 2 plus 2 would be 4. If you had y to the 6th, be y to the 3rd times y to the 3rd, right? So you're taking this exponent here and you're dividing it by 2. So 4 divided by 2 is 2. 6 divided by 2 is 3. If you had y to the 12th, 12 divided by 2 is 6. So y to the 6th times y to the 6th. Now, when you get into things so it's with even exponents. So even exponents divided by 2. That's how you take the square root of it. Odd exponents, you have to do something a little bit different. Okay, so first you have to split it into whatever the variable is to the first power times an even exponent. This will make a lot more sense when we do it. Like it's times the like the even exponent that's left in there. And then you divide even exponent by 2. So you do what you just did in the even one. And then you leave the variable to the first power under a radical. So to have a variable to the first power, like just like in number 6, like n, is like having the square root of 3, right? It's simplified already. So I want to take a look. Let's kind of go down here. Let's go to number 9. So you have 98 times g to the 5th times y to the 5th. Okay, so I'm going to split this up 3 times. So first it's going to be the square root of 98. Then I'm going to have the square root of g to the 5th times then the square root of y to the 5th. Now 98 is not a perfect square, so I'm going to have to split that up. G to the 5th is not a perfect square, so I'll have to split that up. Y to the 5th is not a perfect square, so I'll have to split that up. And you're like, how do you know it's not a perfect square? Well, because that's an odd exponent. So I'm going to make all my, like 6 of my little radical signs here. All right, 98, we did that one on the other sheet, right? It was 49 and 2. If you had to do that math again, that's fine. So square root of 49 times square root of 2. G to the 5th, I need this to be an even exponent. I can't go up to 6. I can't like invent another g in this, right? So I have to go down to g to the 4th. So I'm going to have g to the 4th, and then I'll have 1 g left over here. So you basically like subtract 1 from this odd exponent, and that's what you put in here, and then you keep the 1 over here. So for y to the 5th, same thing. I'm going to subtract 1 from 5. I get y to the 4th, and then I have a y. And unfortunately, I've kind of like run out of room here. So square root of 49 is 7. Rad 2 is simplified. Square root of g to the 4th, remember you just divide 4 by 2, so it's g squared. And then rad g is simplified. And then square root of y to the 4th, 4 divided by 2 is 2, so it's y squared. And then the square root of y is simplified. And now this just looks a little bit funny because I just have a whole bunch of different things in a line. But what you can do is all the things that are outside a radical can multiply together. So 7g squared y squared, and all the things that are inside the radical you can put together too. So times the square root of 2gy. All right, let's go up to 245 c to the 5th times s. All right, so 245, you're going to want your trusty little thing here. So you can start at 225 and go up. I mean, again, or you can, do this by taking out like smaller numbers. So that's not going to work. 196 is not going to work. 169 is not going to work. 245, 144 is not going to work. 245 divided by 121, that's not going to work. 100, we know it's not going to work. 245 divided by 81, that's not going to work. 64, nope. 49. There you go. So it's 49 times 5. So 245. Oh, I guess I did something. I didn't do my first sign of action here, which is split these up into numbers and letters. So 245, and then c to the 5th and s. So square root of 245, we just found out, is square root of 49 times the square root of 5. C to the 5th, I have to split up. So I have to make this even. So c to the 5th has to become c to the 4th times c. And then s, square root of s is just square root of s, right? It's already simplified. It's like having a root 2 or a root 3 or a root 6 or whatever. All right, so the square root of 49 is 7 times the square root of 5. Square root of c to the 4th is c squared times the square root of c. And then the square root of s is just the square root of s. So again, you can do kind of the same thing like we did in number 9 here, where we took everything that was outside a radical and wrote it as being multiplied together, and then everything that was inside a radical and wrote it as being multiplied together. So on my outsides, I have 7c squared. On the insides, I have rad 5, rad c, rad s. So 5c s. So that is my final answer here. All right, so that's how you do these problems. And some of them, again, are, more difficult than others. So do your best, and if you need my help, come on into my office hours on Zoom. All right, I'm going to end it here, and you guys have a good day.